start with this problem. Here it is given that the moment of this force F about point A is 150 Newton meter and moment of this force about point B is 70 Newton meter. Both are counterclockwise, so counterclockwise is positive. Determine F and angle theta. One way is to do this. Let us extend this line and then draw perpendicular from point A to this line of action of force F. And whatever distance we get, multiply by this F. This will give us a moment of 150 Newton meter. Similarly, the same thing if we draw perpendicular from point B to the line of action of force F and multiply by this distance from B, that will give us moment of 70 Newton meter. The another way, that is to resolve, we can resolve this force in two components, F cos theta and F sin theta, and then write the equation to get moment about point A and moment about point B. So this is how we can get this. I am not explaining this straightforward problem. The distances dAx and dAy. We can write down this by assuming that this counterclockwise as positive. We can get this dAx from this triangle because dAx is combination of AD, is summation of AD plus DC and then plus this distance, that is 300 mm. So we can use simple geometry and then we can find out this equation, and converting this Newton meter into mm, Newton mm, we get this. Similarly, we can find out the moment of this force F, both components of force F, about point B. Considering the line of perpendicular distance from this point A and B to the line of action of F cos theta and F sin theta, we get this equation. So these two equations we get, one is this, another is this. Two unknowns, F sin theta and F cos theta, or F and theta. We can make use of substitution method, substitute F sin theta as X, F cos theta as Y to get value of X and Y, and then finally value of F and theta. So this is how we can solve this. The another problem is a slightly simpler one. We have to find out moment of this W and this T about point B. This moment of W about point B can be obtained by simply multiplying W into this distance, because line of action of W is this one. If we take perpendicular from point B, it is this one that is shown here. The perpendicular distance BD is the perpendicular distance, and we can either draw perpendicular from this point B to this line of action of T and multiply T into this perpendicular distance to get value of moment about point B of this force T, and this will be in anti-clockwise direction and moment of this W is clockwise direction. Or another way is to resolve this in two components, T sin theta and T cos theta, and T sin theta will pass through point B about which we need moment, so it will be 0, only T cos theta component will be there. So now calculations can be done like this. We have calculated tan alpha angle as well, though it may not be required here. So then we can find out these values. As we have to write the answers in clockwise direction, so we will be using clockwise as positive in all three cases. So this value will be minus, negative side with negative sign, and similarly this value for this value of T and W. So this is how we can solve this problem. So let us move to another problem where this is given that a force F is acting through point A along AB and OA, that is the length of crane boom, is given as 8 meter, This angle theta is given as 25 degree. We have to find out where to place x. Means B is in our hand. We may shift B so that the force create maximum moment about point O. And what is this moment? It means the line of action of force will change as we change B. So line of action of, we have to find out such line of action of force so that this moment is maximum. For this particular configuration, if I extend this line of action of force and draw perpendicular from this, so this distance, we can get this distance. And we know that for a force to create maximum moment about any point, we should apply force in perpendicular direction to the position vector. As we know, it is moment is r cross f, and r cross f is fr sin theta, and fr sin theta will be maximum when theta is 90 degree, where this theta is angle between force vector and position vector. It should not be confused with this theta. So it means when we have this f in such a way that AB is perpendicular to OA, that will be the block position when this is producing maximum moment. So we can have this type of configuration for this. AB should be perpendicular to OA to get this maximum moment. So now let us consider simple geometry to find out value of OD. So OD will be 8.83 meter as shown here, and then this tan 65 will give us BD dash. This is the additional distance, and our answer will be 9.93 because this is the distance which is 8.83. This additional distance will be added, so x is 9.3 meter, and maximum moment is 32 kilo Newton meter, is in counterclockwise direction. So thank you for watching this video, and subscribe, share and like if you like this, and visit www.engineeringinfo.in to download the notes in PDF form. Thank you.